When metals are placed into water, they're going to form metal hydroxide and hydrogen. So we're going to look at that as a general equation and then use that as a template for various metals. The metals we're going to look at are lithium, sodium, potassium, magnesium, calcium, iron, and copper. Construct your table. You've got to have headings for element, observation, here are the elements, what do you see, what is the nature of the solution, and that's really, is it going to be basic or acidic? And since it's always metal hydroxides are always basic, so we're going to land up with all of them being basic. Well, not quite, but close enough. And then what happens is not all the metals will react with cold water, so we need to find out whether maybe it's going to need hot water or steam in order to be able to actually react, and then you're going to have a balanced equation. So set up this table, press pause, and once you've got the table ready, we can take a look at the actual reactions. Now, the first thing we're going to do is just take a look at the group 1 metals once again. Remember, we store group 1 metals under paraffin. And the reason we store them under paraffin is because they react very aggressively with water and with oxygen. So I'm going to just show you the nature of the reaction with oxygen and also the nature of these group 1 elements. Because remember, I've told you the periodic table is a beautiful piece of poetry where there's rhythm and rhyme and things are very similar. Now, if you take a look at these 3 pictures, you can see that these metals all seem to look fairly similar. And let's see some other things about them. Group 1 metals are all soft. That's another characteristic of group 1 metals. And they all float on water. And we're going to see that in a second when we look at the chemical reactions with water. This is lithium. You can see it's very soft. As we cut through it, it exposes a shiny surface. But if you leave that shiny surface for a short while in the presence of oxygen, you're going to notice that it tarnishes. In other words, it goes black again. That is the lithium reacting with the oxygen to form a lithium oxide exterior layer. If I take a look at well, let's look at sodium first because we're just going to go in order, which is probably better. Again, it's a soft metal. As I cut it, you're going to notice that it exposes a shiny surface, and that shiny surface immediately starts to go a little bit grey and dull. And finally, if I'm cutting potassium, also exposes that shiny surface, which quickly tarnishes. There you go. You can see immediately it's gone a little bit grey. So these are all group 1 elements, and they are all very, very similar to one another. Let's see how their reactions with water compare. Let's go down the periodic table, and we're going to first put some lithium into water. And let's see how that goes. So lithium is popped onto the water. You can see it floats on water. It sizzles around on the water. It's actually melted. And then it's bursting into flame. If I put a flame near it, it makes little pop sounds. And I want you to notice that this water is turning purple. The purple water is indicative of a basic solution. So we're going to say lithium, maybe I should choose another color. Lithium reacts with water, metal plus water, gives me lithium hydroxide plus hydrogen. Now, this lithium hydroxide, I better check what its formula is. Li with a valency of 1 because it's in group 1. Hydroxide with a valency of 1 because it's in group 1. Okay, it is LiOH. Now we better balance this in some way or another, and I'm going to pop a 2 over there, and a 2 over there, and a 2 over there, and I've got a balanced chemical equation. Now let's go down the periodic table a little bit and take a look at what sodium does with water and see if we can notice any trends. So sodium drops onto the water and again it floats. It's melted very, very quickly, sizzling around over there. And it's also easily bursts into flame, and you can see its little melted ball. And they appear not to have put so much universal indicator into this one, but it also will form a basic solution. Let's take a look at the balanced chemical equation, it's sodium plus water gives me a metal hydroxide, NaOH, plus H2. Double check, Na has a valency of 1, hydroxide has a valency of 1, it is NaOH, balancing by putting 2, 2, and 2 in front. Let's take a look, carry on going down the periodic table and take a look at potassium. So, the potassium gets led onto the water, and look, it bursts into flame straight away. Again it floats, again it melts instantly and sizzles around. Highly exothermic reaction. And what you should be noticing by now is that as we're going down the periodic table, the reaction's becoming fractionally more and more aggressive. In other words, it seems to be reacting even better. So at this point, potassium is more reactive than sodium, which is more reactive than lithium. And if we were to continue that trend, we would expect rubidium to perhaps be more reactive and cesium to be even more reactive than that. So we'll look at those in a short while and see whether it's true or not. In the meantime, potassium and water react to form potassium hydroxide. Again, it's a basic solution. It doesn't appear to have been indicated in this particular video. And hydrogen. The potassium hydroxide, I double check, is K. There's one arm because it's in group 1. Hydroxide, one valency, hold hands, and I get KOH. I need to balance that equation as well. Let's just for interest's sake take a look at cesium and rubidium. Even though they're not in my table, you don't have to write anything down. You can just watch whether the reactions do get a bit more aggressive. So, first let's look at rubidium in water. Oh, that seems to be even more aggressive than the potassium, so it seems reasonable that you could say rubidium is more reactive than potassium. Let's take a look at what happens with the cesium in water. Is it even more reactive than that? That appears to be more reactive than the last one. Let's watch that again because it's just fun. Notice the big fat glove. That appears to be a very violent, very exothermic reaction. So anyway, this is a whole bunch of links to various videos of lithium, sodium, potassium in water. Now let's take a look at magnesium. It turns out if you put magnesium into cold water, you can sit there and watch that paint dry, nothing is going to happen. So we're going to take a look at a reaction with magnesium in boiling water, hot water. And it really just looks like some ribbon is going round and round there, but if you put some indicator into that, you will notice that the indicator is going to turn bright purple. That indicates to me that I am getting a basic solution. Even though it doesn't look like hydrogen and magnesium hydroxide are coming off, with hot water it does come off and it changes the nature of the solution. So this is magnesium hydroxide. Let's write ourselves a balanced equation for that. Magnesium plus water is going to form magnesium hydroxide and hydrogen. And then I just need a 2 over there. Just checking on that magnesium hydroxide. Magnesium has a valency of 2. Hydroxide has a valency of 1. And therefore it's Mg bracket OH2. What's a little bit more spectacular is the reaction with steam. So we're going to, they first heat this all up, and then they are going to see what happens with that. Okay, now it's all hot. Now they're going to move over. That's the magnesium that's now nice and hot over there. Now they're going to heat up this water, and you'll notice that there's a flame there. That's because of the hydrogen gas that's been given off from the reaction. So the hydrogen gas, remember what the test was for hydrogen? That it bursts into flame and gives off a pop sound. Taking a look at some of the other reactions, we're not going to actually watch videos of them because they're actually just a little bit boring. Right, so we've agreed that magnesium does not react with cold water, it does react with hot water, and even better with steam. Calcium will react with warm water, and you get, but it looks a little bit like that magnesium reaction, not very exciting. So you get calcium plus, what was it, water, sorry, gives me calcium hydroxide, and again, calcium has a valency of 2, hydroxide has a valency of 1, and then if I want to balance that, I get to that. Iron reacts with water, but very slowly, and then it forms rust, and we all know what rust looks like. So you can get iron to react a bit with steam, but it's not spectacular at all. And in fact, we don't even form the hydrogen gas. All that happens is you land up getting a little bit of iron oxide, and it's not nearly as spectacular. And copper is so boring that it doesn't react with anything, really. It doesn't react with hot water, it doesn't react with cold water, or with steam. So what happens with the iron is you actually only form iron oxide. So it's going to be iron plus water, sorry, and you do get a little bit of hydrogen. And you're going to form iron 3 oxide, so it's Fe2O3, and there's going to be a little bit of hydrogen given off as well. So we can look at that reaction in a bit of detail going forward.